Okay, folks, section 5.6 is the square of binomials. I know I've got a lot of stuff going all over the place here, but I tell you what, let's just start right up here at the top, okay? Remember, a binomial is an expression that has two terms, okay? Now, the square of a binomial looks like this, okay? We write it 2x plus 3 squared, or x minus 7 squared, okay? Now, you guys know how to multiply these things already. We just distribute the terms. Well, first off, we have to write the binomial times itself. So we've got 2x plus 3 times 2x plus 3, or x minus 7 times x minus 7, all right? Now, let's stick with this one for the moment. 2x plus 3 times 2x plus 3, that gives us 4x squared plus 6x plus 6x plus 9. And when we simplify it, we get 4x squared plus 12x plus 9. Now I put notice here. Do you see this right here is a plus, right? And it's a plus because that's a plus. Over here, when we multiply it out, we get x squared minus 14x plus 49. You see, this is a negative because that was a difference up there, x minus 7. So make a note of that, okay? Because that'll come up when we're factoring some stuff. Now, you guys know how to multiply that out. We don't need to spend any more time on that. But let's look at this next bit. It can be very helpful when factoring to be able to identify or recognize perfect square binomials. Okay? For example, let me put some colon in there. All right? 49x squared minus 42x plus 9 is a perfect square binomial. It's what we get when we square this binomial. Oh, I need to put a square up there above that. All right? That's why that needs to be there. Okay. Now, you can recognize it, and here are the three questions that you answer to determine if a trinomial is a perfect square. All right? Question number 1. Is the first term a perfect square? Okay, we look up there at 49x squared. Yeah, it is. Okay. Is the second term a perfect square? Plus 9. Yeah, that's 3 squared. Okay. And then the third one is the one that we have to spend some time on. Does the middle term equal twice the product of the square roots of the first and last term? Don't worry about the sign of the middle term, not yet, okay? Now, let's go down here. I rewrote it so we could look at that problem as we're factoring, okay? Now, first question, it says, is the first term a perfect square? Yes, it is. The square root of 49x squared is 7x. 49 is a perfect square, it's 7. And x squared is a perfect square of x. Is the second term a perfect square? Yes. The square root of 9 is 3. Okay, so far we're good. We've got yeses to both of those questions. Now, the third one, it says, does the middle term equal twice the product of the square roots of the first and last term? Now look, we got the square root of that, it's 7x. We got the square root of that, it's 3. And this question says, does the middle term equal twice the product of those square roots? Well, what is 7x times 3? It's 21x. And it says, does it equal twice that? Well, what's twice 21x? 42x. Well, let's go back up here. Oh, look. The middle term does come out to be 42x. But remember earlier I said, take note of what this sign is. That sign right there tells us that it is going to be 7x, the square root of the first term, minus 3, the square root of the last term, squared. Okay? Now, we're going to do a lot of practice with this, so be ready for it. But you've got to have your thinking caps on. All right? That's all we're doing. We're multiplying, or we're squaring binomials, and then we need to be able to recognize them. And we recognize them by these three questions. All right? Great job. You're ready to go.